We drove 3,000 kilometers all the way from Ukraine to the village of Orlo, located in the southern part of Netherlands, to demonstrate the autonomous tractor AgXeed in operation. Creators of the future tractors agreed to demonstrate to us how it works on the fields of local farms in Netherlands. We drove 3,000 kilometers all the way from Ukraine to the village of Orlo, located in the southern part of Netherlands, to demonstrate the autonomous tractor AgXeed in operation. I'm very excited to learn the basics of this futuristic machine, how it gets started, and how it handles its given tasks. So let's take it to the field. And now we are going to the field, where we will see how this tractor without a cab and without an operator will work together with the Amazon Senio unit on the field of a Dutch farmer in the village of Orlo. Here we are on the field with Philip. Philip is the head of marketing at AgXeed, and he will introduce us to their amazing autonomous technology.
Philip, please tell us everything from the beginning. So we came to the field.
Yep.
What are the next steps to launch it? How you unload it?
Okay. So before we went to the field, we set up the task in the web portal. So everything the robot is going to perform was planned in advance on our web server. So on the web server we have the field boundaries, we have a digital image of the tractor, and we have a digital image of the implement in the front and in the rear. And digital means we have all the dimensions, the type of steering, the length, the width, the working depth, etc. And then I set up a task like you do with your GPS system. So I tell him, okay, you should stay off 1 meter off the boundary. I want to have an overlap of 5 centimeters. And the routing mode. Routing mode means should he skip 1 line and then come back, or should he skip 3 lines? That's the next thing I put in there. And then I decide everything in regards of working depths, speed, traction control or position control, like your tractor. So basically the portal is a mixture out of a kind of farming management portal with wayline management and headland management. So, and then the portal automatically calculates the lines into the field with all the so-called set points. And set points means the in-work procedure, so that's where the tractor accelerates, where he lowers the hitches, And then you have the work lines, so that's the AB line, which you know from your GPS systems, and the out of work points. That's where he slows down, lifts, switch on, off PTO, whatever.
Do you send it remotely to the tractor straight away?
Exactly. If I like what I see in the what's automatically calculated, I push a button and then it's sent to the machine. So, and then I load the machine, I come to the field, and the next things are that I unload the machine by unchaining it, and I do this with a remote control. So we decided for having a real remote control, like exactly what you said with your drone, because controlling a machine in the field while working and looking is not very handy if you do that on a touch screen, because you have got dirty fingers and everything I put via the portal onto the robot in regards of speed, turning circles, depth, I can now adjust with the remote when I'm in the field, because cultivating, disking, disc curriculum, whatever, you can plan from your office, but you never know how it's going to look like in the field. It could have some sun or some rain in the night, so you want to adjust. And that's the reason why all the hitch control and speed controls are also on the remote, and I can adjust, and then they are set as offsets on top of the task. And if I like what I see in regards of the cultivation or drilling or whatever,
You can leave the field and go home.
exactly.
The first thing that could be said is that it weighs 7 tons. Although it looks much smaller, I would say 2 to 3 tons. But in fact, we see 7 tons for the entire mechanism. Inside is a Dmytro engine, 4-cylinder, capacity of 160 horsepower. The tracks, I think, are very similar to the Class tracks.
Is it like a class design or no?
No.
No?
It's basically the first one you saw at the location was coming from Zoidberg. So most of the standard components are from Zoidberg, but it's our design. So we developed it in cooperation with Zoidberg.
And the trucks as well was designed for you specifically? Or you
No, this is a Kamsoi of...
So, let's start.
Okay, I turn the key.
What?
Now the robot has been connecting to the remote, and now the remote tells me what I have to do. The first is press 1 to enter remote mode. So, and now he starts up the connection. So he verifies is the right remote control present, are all CAN bus messages on the bus that should be there, and once he is ready, I get the actual working screen. And now he tells me power the ECUs by pushing number 1. And now he tells me push the button to start the engine.
Okay.
That's when I push the button to the left, then he gives me more revs on the engine.
Oh, okay.
Now we call it, now he's charged. With the left button, joystick, I can do forward and backward. And with the right button, I do the steering, the left and right.
Don't do now, on the platform.
So now the robot is heading towards the field, and we have a boundary in the field. It's not exactly the boundary of the field, but inside.
Okay, okay.
So now the robot tells me via the yellow light that he's fine, but he's not inside the boundary.
Cool.
As soon as I now start approaching the boundary, and green means
he's in the working area, yeah?
exactly. Inside the boundary, I do have a task, I'm happy, so if you would like to, you could start. And now the the remote control tells me that he is 360 meters off his starting point. By pushing 2,
it will go to the starting point
exactly.
itself.
Yeah, exactly.
Okay, stop.
So by pushing 1 and forward, now he goes into the so-called auto guiding, and now he follows a line on the headland, and now he says, I'm ready to go.
This miracle is driving across the field, and our task now is to go to its starting point and simply adjust the cultivator to see that everything is working correctly. If we are satisfied with the quality of work, we press start and go to the office to warm up. It will work here without us.
So we will now send him to his first working path, and then we will adjust the cultivator that we like the working quality.
Okay.
So be careful, I don't know where he's going.
Start.
Push the button and it's on its way. It goes to the starting position. We will now enter the first line and drive a little. We will stop to look at the quality of the cultivation, to see if we like the quality or if we do not like it. I think that it is unlikely to like it in such weather, but the principle is that it drives to its first line, you look at the quality of work, and if it's satisfactory you press start. That's it. The tractor drives, does the work, and you can go do other things. The technology really works. I hope within the next couple of years it will work on my fields.
This is a 115 kilowatt machine. So we have here a Deutz diesel engine with 4.1 liter stroke volume. The diesel engine is directly connected to a generator, and the generator generates electrical power. And the electrical power is distributed to the tracks by having an electromotor integrated in the tracks.
Okay.
And the electric motor is connected to a final gear. So the electric motor is running on high revs, and the final transmission is reducing the speed to the working speed of this machine. And the working speed of this machine is between 0 and 13.5 kilometer per hour. This machine with almost 350-360 liter of diesel can run at an engine load of 75%, round about 20 hours without stopping. If we want to do this with a battery of today's technology, we have to add a battery of about 6 to 7 tons.
6 to 7 tons. Explain us the way it works with the... in this case we have cultivator, but what if you have something where you need PTO? How do you work with this?
There is a PTO.
Yes. PTO presented.
Yeah, there's a PTO. But also the PTO is electrical driven. So there's no direct connection between the engine and the PTO. The PTO has almost the same electromotor like in the track system. And that means we can run the PTO between 0 and 1200 RPM, clockwise and counterclockwise. So if this machine would be connected to a simple mulcher, not an electrified mulcher, in the portal we turn the driving direction, and then the machine would just drive in reverse mode. If there would be a rotor harrow in between, he does that direction, and we tell the PTO to turn clockwise. But we also can give direct electrical power by a plug, and there we follow the AEF isobus standard, which is based on our system on 700 volt, and we can give almost 100 kilowatt based on 700 volts directly as electrical power for electrified implements.
Wow.
So The modular concept is unique. We also developed together with Zoidberg our own track system, and on the track system we have a specialty. Since the electromotor is integrated into the tracks,
Yes.
there's only a cable between the chassis and the tracks, and we have a seamless adjustment between 1 meter 80 to 3 meter 20. So on these tubes here, we can shift in and out the tracks.
Wow.
And we provide tracks on 300 millimeter, 400 millimeter, 620, 760 and 910. So if you're talking about the 300 millimeter track for row crop application,
Yes.
we could do 180 or 320. Yeah, and so we have already farmers asking for having 2 sets of tracks, a wide one for the broad applications and a narrow one for do hoeing or
Inter-row application.
inter-row application, exactly.
Wow.
The track system, we have a pivot point here, and in the front it's connected to 2 shafts, and that means that both tracks can move, and also the idler wheels can move up and down.
Wow.
So the track system always adapts to the surface of the soil.
Cool. Tell us more about GPS and the way you done it. It's your own development, or you're using some producers?
The receivers are coming from a supplier. They are not special, but behind we do everything on our own. So we only use the GPS signal, and then the GPS is directly connected to our robot or ECU. So we calculate the heading, and we calculate the following of the track. The advantage we have is that when we do the task in the web portal,
Yes.
we send a complete task to the robot, and the robot only is check marking small tasks. And in this task we have always the position and what you should do in regards of speed, heading and cultivator. And we can drive very straight, also due to the fact that both electromotors left and right are independently.
Okay.
So that
So
means
they can adjust.
exactly. So if you look to your track tractor,
Yeah.
you've got the differential, and you have to break down one track system. We never break down, so we always have the right revs on the left and right track to follow. So if we make a turn on the headland,
Yes.
we know the left speed and the right speed, and we actively control those speeds to make the turn. That's a big difference to tractors. If we look to the rest of the concept, we are also using parts that are standard parts, well known in the agricultural sector. For example, our lifting and hitches in the front area are designed together with Walterscheid. Yeah, our hydraulic system is a well-known Bosch Rexroth lift control system. We are also having standard auxiliary valves on this machine. And the idea of AgXeed was that we don't want to build in first instance a special robot or a special autonomous vehicle. We want to invent a vehicle that a farmer can use right off the box. So that's the reason why we went on with a 3-point linkage, so that the machines on the farm can be used. So in the front we have a category 2 front linkage with a lifting capacity of 3 tons, and we have a category 3 rear point linkage with a lifting capacity of 8 tons. But we have also, so the frame is also designed to put something on top of the machine. So in total we can...
So for example, you can put a trunk with seats, yeah?
Exactly. So for example, if you're thinking in a seed or something, we think doing cultivation in the front, the weight on the top, and then in the back the seeding. By this you have a perfect distribution of your weight. Yeah, and that's the idea. And we think that in the loop of the years, implements will look different, because you don't have a cabin anymore that is a kind of factor that disturbs the environment, more or less.
I get it. Nice approach. What do you think will going to be the starting price of this implement?
We're talking about around 250,000 euros ex works without VAT.
Yeah, okay.
Understood. Guys, 250,000 euros. Well, a solid price, but it seems to me given the salaries that you must pay to the tractor drivers.
What is the average hourly rate in Holland for tractor drivers?
It's between, so for the farmer, what the farmer pays in the back is around 90 to 21, 23 euro, where the operator gets 13, 14 euro. In Germany it's slightly lower.
Okay.
The average salary price is 20 euros per hour. So count how many hours you need to work on a salary to pay back. In fact, this is a payback story, very big payback story, given that there's a shortage of personnel, and for most operations, this is already a working option.
But do you think it's going to be cheaper in the future in terms of like mass production when you would launch it?
I wouldn't say so, because the benchmark of the machine, I would even say that 250,000 euros is quite cheap, because if you really calculate the return on investment, you save at least 20 till 30,000 euros per year for your operator. And since the machine is so simple, so no transmission, no cap suspension, no front axle suspension, you save a lot also on the maintenance.
100%, yeah.
So the capacity of this machine, even with 3 meters, is incredible high, due to the fact that everything is so accurate. Every turn is the same quality. You can't compare to a human operator, and that's the reason why I think the technology needs to be paid by that price.
There are many competitors who's planning to launch this.
Right now, in regards of robots and autonomous machines, we don't think so.
Yeah.
Our competitors in those days are the comparable tractors. Okay. But we compare ourselves towards tractors around 200 horsepower, because to achieve the same efficiency, you need more horsepower with wider implements to do the same work. And so that's our benchmark. High spec tractors around 200, 220 horsepower.
Okay. But do you have the plans to launch more powerful engines in the future? Because like back home we need like 350, 400 horsepower.
That's a point to discuss, what we would like to discuss with you, because our basic idea is that we should do, instead of one 300 or 400, do 2 of those. And again, if you come back to the total cost of ownership, foldable implements are very expensive. And if this one big tractor fails, you can move on. But having 2 tractors doing almost 20 hours a day, you achieve the same capacity.
Philip, I would like to say thank you.
Okay.
It's a really interesting demo you done for us. We would like to wish you good luck, and we hope that you would come to our farm as the best and the most innovative farm in Ukraine, and we would be the first one to launch it back home in Ukraine, and we hope it would happen as soon as possible.
Thanks for the invitation.
Yes.
And thank you for coming.
Yeah, it was really good.
Well guys, outside is 0 degrees, cool and windy, so we start the tractor and go to drink coffee in the office. Let it work without us.
So please show us how do you control machine remotely, and how do you operate it remotely?
So now you've seen the machine in the field, right?
Yes.
And what Philip did beforehand was the planning, the whole planning. So this is what you didn't see, this is what I'm going to show you now. And this is basically done in our own proprietary portal. Settings here, so this is the dashboard. But keep in mind, this is still a bit under construction, so not all functionalities are there yet. but we are able to plan tasks and do the routing as you've seen, so it works.
Is it some special software, or you go to website and it's all web-based?
This is a special software.
Yes.
It's especially designed from people in-house. So basically the software is web-based, which means that you can access it from everywhere you want, from your browser. So you're not, of course you need internet connection, but other than that, all the calculating power, so to say, is in the portal or is in the cloud. So it's not in a machine, so that why the machines won't get old that easily, because all the power basically is inside the portal and inside the cloud.
Joris, please tell us a little bit about history of your company and how you and your team came to this idea to create autonomous tractor.
Yeah, the idea came from a lot of different angles. So our team was working in the past for John Deere, Echo, Lemken, all these kind of companies. So we have quite an experienced team. And customers were challenging us more and more. Are you working into the right direction? Can't you come with more clever solutions? So we have problems with that the machines are too heavy. We have problems that we don't have the labor anymore. We want to go to a more sustainable world. The regulations from government are becoming tougher and tougher. And you are only working on more horsepower, bigger tanks, only bigger. And then we had a couple of ideas that we saw also what was going around us with technology, and we decided we can come up with better solutions, and let's start to do it by ourselves.
What was the starting point in terms of like from idea to some action?
We are with 4 founders, and one of the 4 was challenging me a little bit. You always have ideas, other ideas. How do you want to continue? And then I said, I need money. He said, if somebody is going to arrange the money for you, can we then start doing something else? And I said yes, and then we 4 came together, and we made a business plan, a PowerPoint presentation, a kind of concept, and that was the starting point.
And when did you first launch your robot in the field?
That's already exactly 2 years ago now.
Serial production, what are the plans? And how do you planning to expand it in general?
Not everything is clear, but we want to keep it as simple as possible. So we think that we need a track version for the heavier implements. And now the question is, what is heavy, and do we have to go in the same direction as tractors, or can we do it with less horsepower and a little bit smaller machines? But then autonomously, and that means that the machine will then also be very, very simple in comparison to a standard tractor. Then we don't need
it's already simpler than a tractor.
Yeah. We don't need a gearbox then anymore. We don't need a cab anymore. We don't need an airco or a suspended axle or all these kinds of things. So basically a pretty simple machine. And the idea is that most of the intelligence is not coming from the machine itself, but from the cloud. And there we are doing the calculations. Basically headland management, variable rate control, section control, the planning tool, everything in the cloud. Then we make a very simple task of it, send it to the machine, and then the machine can execute a simple task. That's more or less the idea.
Do you have the orders already to buy it as a serial model, and what are the plans for production in terms of number of units?
What we are going to do next year is that we keep it very low, the volumes, so max 20 machines and very likely even less, so that we can control by ourselves these machines. And then the year after we want to do a small series of tractors, or machines actually. And then see where we are, how the customer reactions, and then the year after we will really go into production. That is the idea.
Cool. Is there any plans to go to complete electric tractors? Or do you have
Yes,
this concept?
absolutely, because actually that's quite simple for us, because if we take the diesel engine out and we place an alternative instead of the diesel, then the machine is already electric. The problem is that batteries are, if you are talking about energy per energy density is in batteries not good enough yet, so we have to go 2 times and actually 3 times higher than where we are now. So there has to come a new type of technology, for example, solid state battery. Otherwise it will go to fuel cell technology, and that is also becoming very interesting. So we are already looking to that.
Okay, thank you, Joris. Thank you. I would like to wish you good luck, and I hope that my farm in Ukraine going to be the first one who brings this technology and will demonstrate it to people.
That would be great.
Yeah, so we're looking forward for you to complete all your plans. We wish you good luck, and thank you
for
very much.
visiting us.
Let's admire what is happening on the agricultural market together. Dmytro Hrushetsky was with you. Please subscribe to our channel, put likes, bells, and we will make more of this interesting content for you.